Hello, everyone. Welcome to Control Automation Day 2022. My name is David Peterson. I'm the Director of Engineering Content here at Control.com and your host for today's keynote. We're excited to bring you all kinds of educational resources that are designed to help you succeed in a fast paced, always changing industrial environment. For those of us with a background in control field work, we know that hardware and troubleshooting are critically important to the success of any control system, but we certainly can't overlook many of the changes that are brought on by Industry 4.0 and other modern advanced technology. Our first keynote address today is by a well known company in the world of industrial controls, and that is Rockwell Automation. I'm joined by Global Business Director for Control and Visualization, DeYoung, as we discuss the past evolution of Rockwell PLC technology, as well as looking at some of the current trends that shape where PLC technology has brought us, as well as looking at some future projections of what the world of control systems may look like in the near and distant future. Dan, thank you so much for joining us here for our first keynote for Control Automation Day 2022. We really appreciate that you had the time to be able to join us today.
I appreciate the opportunity to get together with you all and look forward to our discussion.
So, to get started, we thought we'd give a little bit of a background to both you and to Rockwell before we get started talking about what the current and the future trends might look like. It might be kind of nice for some of our audience to learn where things started and how things have evolved. So, can you give us just a little bit about your own background, how you got interested in engineering and technology, and where the spark for control automation really started for you?
Excellent. Thanks, David. Well, I grew up in the Midwest outside of Chicago on a small family farm. And so my father was the first in our family to go to college, and he went to Purdue University, so kind of a notable school there in the Midwest. He and my grandfather both were really would be ultimately practical engineers. They could fix anything, they could design anything, and they kind of did it all, at our farm. We had milling machines and lathes and all kinds of stuff that we could make things. And so, where my dad went to school and had an agronomy degree, when I was in eighth grade, he ended up purchasing our first family computer. And so we had an Apple II computer showed up at our house back then, and I kind of started to tinker with it. And so I kind of started to, fall in love with that aspect of it, and had a bit of a practical, given my dad and grandpa's point of view, a bit of a practical experience with it, and started to, instead of being much of a gamer, apply it to more practical things that we dealt with. And so I did a science fair project one time that was using the joystick port and integrated with thermistors. And then I wrote a program that actually plotted the temperature of a chemical reaction. And so, kind of an interesting thing that started to get me into computers in a practical way. And then I went off and followed my dad to Purdue, and I started off in software engineering thinking I wanted to be a programmer. And shortly after getting there, I learned of this program called Computer Integrated Manufacturing. My roommate happened to be in it. And so I made a shift and went into that path. And from that point forward, that's really where I discovered automation. It's where I discovered Rockwell Automation and Allen Bradley Company and the products that they offered. And it charted my course down that path. And the notion of computer integrated manufacturing is kind of a 30-year-old concept, but today we know of it as smart manufacturing, digital transformation, industry 4.0. What we were doing then was really a precursor to all of these ways of describing integrating things in a more effective fashion and driving productivity out of them. So while I was at school, I worked on, luckily, a bunch of Allen Bradley equipment. And so our labs were made up of PLCs, PLC2s, so really old stuff. But we had PLCs, we had robots, we had milling machines and lathes, and we were applying, kind of at the time, modern principles to them. And so my senior design project while there was to build basically a warehouse management system using robots and barcodes and Visual Basic programming, so pretty basic stuff back then. But I kind of assembled this whole system together and using a good bit of Allen Bradley and Rockwell Automation technologies. And so, folks that went through my program, the pinnacle place to go work was Rockwell Automation. And I happened to be out of our class, the one that was chosen because everybody interviewed for it. And I happened to be the one that was chosen from my class to get hired on by Rockwell. And almost every semester, they were hiring somebody or more than one from our program. And I was the fortunate selected one that particular year, and I've been here ever since. So.
Awesome. That's a really fun story. I think that probably resonates with a lot of people. I actually myself too. I grew up on the family farm, and my dad and grandpa still run the farm, and it's nothing more than a family farm, but it's that spirit of fixing the tractors, and he's got the milling machine and the lathe in the shop. So, boy, that sounds so familiar. I find so many people that have a similar background to that. So you've been at Rockwell for 30 years. So curious about when you said you first got hired, selected from that class to go to work for Rockwell. What was that entry level job that you first got started with? What were some of those tasks that you accomplished as you were first getting entered into that world of working in control automation?
Yeah, so the world that I stepped into when I hired into Rockwell was what is our services organization, and so I effectively ended up going into what would be a graduate program. So I started, in the first day I was at Rockwell. I was in training classes, and I spent my first 6 months in super deep dive into our latest controller technologies, our latest software, and effectively my life for those first 6 months was a lab of stuff. And so they had outfitted us with all the latest and greatest technologies. I had a brand new computer and every cable, multimeter, all that kind of stuff. And it was really kind of an empowering part of my career. And luckily, when I at the end of that program, or during the program, you were actually asked to identify where would be the top 10 places you wanted to go be a field service or field application engineer person at Rockwell. And so we made our list, and we quickly realized that what you put on that list wasn't where you were going to go. You were going to go somewhere else. And so I ended up going to Louisville, Kentucky. And it was a wonderful experience. I didn't know a lot about Louisville at the time. Somewhat of the mystique of going to Rockwell and the program I was in is you didn't really know where you were going to go, and you kind of got to explore and apply these technologies that you were educated on. Yeah, so shortly after I arrived there, I was asked to go participate in a very large automotive company over in Lexington. It was their first manufacturing facility in the U.S., and we had recently secured some of the systems at that facility. And so I was a 6 months hired on engineer working at Rockwell in the field, and I was supposed to go there for about 2 weeks just to see a big program going on, and then I was going to go off and do other things. And so after being there about 4 days, it became apparent I was going to be there a lot longer than 2 weeks. And so I spent the next 3 months living out of a hotel, working at this facility and helping them get the automated vehicle tracking system that we were installing there up and running. And so the claim to fame I have in a matter of months of having been in the field and working at Rockwell and at this facility was I wrote the program that spit out the VIN label that was coming out of that facility. So it was a pretty neat thing, pretty all things considered a pretty simple thing, but for years and years thereafter, I was the person that made that thing work, and so it was kind of a fun thing to know that several hundred cars a day came off of that line that had my little contribution to it. So kind of a fun time. And then fast forward, shortly thereafter, they doubled the size of that facility, and so I was called back to the facility and spent the next almost 3 years embedded in that facility while we installed a massive amount of our technologies and products. And I was the local guy. So we had 20 or 30 Rockwell colleagues working there on big projects during that period of time. But I was the local guy. I lived next door. And whenever anything went awry with the startups that were going on, my pager went off, and off I was, hiking to wherever it was in the plant. And so it was an incredibly formative time. At the peak time, there was about 1,000 electricians working on site every day, from machine builders and equipment providers from all over the globe. And so it was a massive undertaking, and an incredibly formative time in my career. So I learned a ton, and to this day, I still look back on experiences that I had while I was there.
Boy, having contributions like that sounds like so much fun. So just because we know that the theme this this control automation day is PLCs, programmable logic controls. You mentioned that when you got out of college and got hired, you spent 6 months in a lab with high tech equipment, and I think if I recall correctly, that was right about the time when the Slick 500 was first being released. So, what would you say are some of the biggest changes? What did that really look like then in terms of PLC technology as we look at the evolution of that from then to what it looks like now?
Yeah, so we were in the thick of Slick 500s, PLC 5s, which was a generation change from that version of controllers I used at Purdue. So that was an older family of controllers, as often happens in universities. They have hand-me-downs. But when I stepped into Rockwell and was working on the latest and greatest at the time, it was PLC 5s and Slick 500s, and even some of our bigger systems, 5250s, and some other things like that. I was every week was another a week of training on different aspects of those control systems, and so it was the latest and greatest. And what I didn't really realize until later in my time in our services organization, we really invest in those folks that are coming out of school. They have usually the latest and most contemporary knowledge from a university perspective. And so when we hire them in, we kind of pour the latest and greatest products, technology into their head. And then when they go out into the field, they really quickly become the expert on those products. And so that was my experience. And we've continued to do it to this day. But the controller technology at that time had just been transitioning from what I had at Purdue was really cryptic. If you were to look inside of the memory map of a controller at that vintage, um, if you didn't know what was going on, it didn't mean much. There were no letters involved. Everything was numbers. And you're using octal memory addressing schemes. You're using RS-232 and really basic slow communications. The amount of memory in these things was measured in K. It was there was no megabit memories and things like that. So it was a whole nother paradigm than what we have today. And I think as we go through the discussion today, I'll talk a bit about how that's evolved over the course of time.
Yeah, well, I've only gotten a brief exposure to some of the old ones, but up here in the Pacific Northwest, there's a number of facilities that I've got a chance to work with that have the mixtures of some PLC 5 and some Slick 500 and some brand new where the communication has to play between all of them, and now introducing some of these new technologies that you mentioned and we'll discuss more about. So those kind of systems I think are kind of fun to play with and learn how the generations have evolved.
And it's interesting to see there's roots of those old systems continue to exist today, so that it makes, and we'll talk more about it, I think, as time goes on here, migrating more possible. But there's linkages to the old and the new that in most vendors in the space you continue to offer the market.
So if you could take what you've got today, the brand new latest generations of processors and IO technology, if you could take that back and show that to yourself back when you were just getting started as a field service engineer, what kind of things do you think would be the most surprising, just the shocking things that you never expected to see in a PLC 30 years in the future? What would that look like?
A good question. I think when I was first working in those PLCs, a PLC was a discrete logic focused system. And so if you had to do, control a drive system, or if you were controlling servo systems, robotics, and things like that, most of those required a separate controller. So there was a robot controller and a PLC. There was a motion controller in a PLC. There was a batch controller and a PLC. And what has evolved over the course of time is we really have fused together a whole bunch of those disciplines. And today's PLC kind of does all of that. It can do robotics, it can do process control, it can do batch, it can do sequencing. And that experience that is all woven together allows maintenance people, it allows engineers not to have to know such a wide array of vendors' products and technologies as they historically did. Much easier to maintain as a result.
And I think that that description that you just gave is kind of what I've understood as being maybe the terminology difference between PLC and PAC. I
Yeah.
think it's still kind of synonymous in a lot of ways, but I think that look at a entire automation system in one programmable controller and not just the logic is really what the difference technically is between the PLC and the PAC. At least that's kind of what I've understood.
You're spot on. They're also, today's modern controllers is just significantly more performant. The amount of I/O, the amount of axes of motion, the complexity of the system, and we'll probably talk about a bit more of that here in a bit, but it's changed a lot over the course of time. Controllers today have megabytes of memory, and the amount of content that resides in them is, was unfathomable back in the early days.
So now as we move kind of from those early days and looking at what's changed, what would you say are some of the biggest trends that are shaping what industrial automation looks like in a typical factory setting these days, those trends that the industry is moving towards?
Certainly, there are applications that would have historically never been automated. And so the number of things that are being automated has exploded. If you go back in the back of a Walmart, the trash compactor where they're smashing the boxes, back in the day that would have a hydraulic cylinder and a couple push buttons and that'd have been it. All of those types of equipment now have an automation controller on them. And so the diversity and the breadth of these systems has become quite vast. They're much more modular, and the scale, the small controllers to large controllers, is much more vast. Also, integrating these more advanced disciplines, robotics is becoming a key element of an automation controller. And the newest ones we'll spend a little time talking about disciplines are AI and machine learning are becoming very critical topics to complement the automation controller. More contemporary languages, above and beyond the classic ladder logic or structured text or function block, things like Python or Node-RED, those are all becoming important topics. And I can't talk about this without mentioning security. There's almost nothing we do anymore where security isn't a critical part of the discussion on how we're engineering it and then how customers ultimately can assure that their systems are as secure as possible.
Yeah, and I know some of those we'll come back to talking about, but particularly things like security and machine learning, artificial intelligence, I found that those kind of things are sometimes difficult topics to approach because they happen in the background. They're invisible, and sometimes engineers and technicians have a hard time dealing with the invisible. And so I know those are important, very important topics, but they're sometimes very difficult to teach and address properly.
Yeah, it can be it certainly can be that has, it's one of those topics that has some mystique about it. And, what we've attempted to do is be very transparent and provide a lot of educational content, dispelling some of the mystery of the topic. And, I think there's been a lot of progress in that regard over the last 10 years or so. It's continued to become more of a comfortable topic in spite of the fact that you certainly still encounter scenarios where it's not well understood.
Yes, absolutely. So instead of just the industries in general, what about the customers? When you talk to the people who are integrating or the end users of the systems, what is it that they're asking for? And I know we kind of need to take that sometimes with a grain of salt because sometimes what people ask for isn't necessarily. I always bring to mind a quote I think that's attributed to Henry Ford, where he says that if I'd asked people what they wanted, they would have said faster horses. So sometimes we need to I understand we need to respond to what people are requesting, but that doesn't always mean it's the right business decisions. But when you talk to those people, what is it the things that really seem to appeal to them, the things that they connect with and really drive their desire for more PLC technology?
For us, one of the things that really stands out is the user experience and making it as simple as possible, such that a wide cast of the audio users can take advantage of it, whether it's maintenance folks, whether it's machine builder designers, whether it's plant engineers. The folks that interact with automation come from many different walks of life, and you know depending on the industry, that varies dramatically as well. If you're in the oil patch down in Texas, or if you're in an automotive plant like I mentioned, or in a food processing facility, there's just a wide array of people that are involved in working with automation. And so the user experience and the interaction is paramount. You can have the most technologically advanced solution, but if people can't understand how to use it reliably, and in many cases, one of the dynamics that's true of automation, the person who's maintaining it wasn't the person who designed it.
It's true.
So if it was the designer that was maintaining it, you'd probably be able to do something different. But if it's the nature of these systems is that the person who's maintaining it, they never were involved in designing it. And so you need to be able to kind of transcend both of those personalities and both of those experiences in a way that allows them both to appropriately be able to design the system. And then when it comes time to maintaining it, the maintenance person is able to do it without a lot of complexity as well. And so that's a pretty tough challenge. It's one that we aspire to, and we spend quite a lot of time evaluating and engaging customers on optimally constructing the user experience.
Yeah, so it sounds like the challenge is what you're trying to do is do everything for everyone. Sure, that's not known for being an easy task.
Not an easy task. You add in all of that industry variety. You add in those disciplines we talked about a few minutes ago. Doing all of that at scale and then increasing and adding functionality over the course of time, it's quite a complex scenario that we live in, but we really enjoy it, and we're pretty proud of where we're at right now with our
Yeah.
capability.
I want to go back to those topics with that mystique that you were talking about, the ones about IIoT, that industrial Internet of Things, and in Industry 4.0 technologies or smart technologies, or whatever the, I guess, buzzword of the day is that's going to refer to those sorts of things. How do those all fit together into the scope of the physical PLC that people are used to seeing? How, in what ways has Rockwell addressed the introducing and integrating those smart technologies into the physical hardware of the controllers?
It's a great question. And you mentioned the word that there's buzzy kind of words that are used in this space, and I agree with that. I mean, there are a lot, and because you could have, the word edge right now. If you talk to 10 different people, it probably meant 12 different things. And so, the permutations and the meanings of these things vary quite significantly. In our case, what we're trying to do is bring these new technologies and new capabilities, like the disciplines I described that we've already engineered in. We're working to bring these to the table as well. So that safety control you've been able to do for years, that'll continue to be there, but you'll be able to complement it with machine learning capabilities, be able to complement it with AI capabilities, optimization capabilities. And so have them both be able to exist. And in some cases, we're doing this where we're bringing a module that lives in our existing control system. And in other cases, we're going to integrate it in. And so we're doing it in a hybrid way that can allow an existing system to just be upgraded or had a component added to it. And in other cases, you may do in a greenfield scenario something ground up in a bit more directly integrated way.
Yeah, and I imagine that there's for every company, each one of them has a completely unique set of circumstances that define which is the right thing for them. I know it's an impossible task to say what do you recommend a company should do. That's an impossible question to answer. But if we imagine that greenfield ground up scenario where maybe money is absolutely no issue, what would that look like in terms of what kind of hardware, software solutions, the add-ons and things like that? What would you recommend as being not necessarily pieces of hardware specifically, but considerations that might help them to improve those processes, not just today, but well into the future?
So I think to answer that question, it's really best to kind of have some context. And so if this was an automotive scenario, the answer would probably be quite different than if it was a food manufacturing scenario or an oil and gas environment. So context is critically important to provide the best answer there. But in most cases, I guess the beauty of automation is it's fairly ambidextrous. And so there's some common elements used really across most of these industries. And the automation controller is kind of the epicenter of that. And so clearly some type of control is required, and so you're going to be plugging in a variety of sensing elements. You're going to be driving a variety of outputs. Maybe they're variable frequency drives, maybe they're servos, and so you go through and identify what all of those apparatus are and what sort of mechanical elements, what sort of process elements need to be controlled, and then you ended up assembling the optimal collection of automation gear, both controllers and software that's best tuned to do that kind of an application, and then complement it with if you're really trying to drive optimization, maybe some machine learning technology or some AI technology. And then it probably doesn't stand by itself. It probably is a part of a bigger system or a bigger line or a bigger plant. And so you kind of have to step back and look at how is it going to plug into the manufacturing execution system? How is it going to plug into the maintenance management system? And so it becomes kind of a system of systems conversation that has to be evaluated in order to choose the right controller, choose the right IO. And so all of those factors kind of have to come into play to make the right choice.
And so it sounds like considering all those factors, a really major component of the discussion for any facility would really be those communication protocols that allow it to interact with so many different systems. And I know that there's just so many different communication protocols that are out there, and plus looking into the future, who can really with the crystal
Yeah,
ball tell exactly what it's going to look like. That communication element seems so important.
yeah, and I would have that part of the consideration focus on the data. So, what sort of data resides in the system that you're going to use to make additional decisions? Um, And so the data then that is being used, how is the data structured? So how much do you have to move around? And so all of that then translates into what does the communication need to look like? And the good news is the communication infrastructure that exists today is quite performant and quite accommodating. And so it becomes more of a discussion around establishing the right context in the control system, and then plugging that into the ancillary systems that some of which I mentioned, so that the right data is moving around to the right complementary systems. But communications is critical, data is critical, and the context of the system is critical.
So now that kind of addresses the idea of what if somebody's starting from the ground up. But I think probably far more people are in a situation where something already exists. I imagine that's quite a luxury, being able to have infinite funds to build a brand new system. That must be a very fun project. But for most people, they're looking at a system that already exists and facing that question of when and how to go about doing an upgrade to a system. So I'm just kind of curious on your thoughts. Just what are some of the symptoms? What are some of the signals that might indicate that it is a good decision or a good business decision to making a purchase of upgrading either part or complete systems?
It's a great question and a very fitting topic for today. If you're having a hard time getting maybe spare parts for the system you already have, you're surfing eBay, trying to scour an I/O module or a drive component in order to repair or have some backup. Or you may have a scenario where the operators or the maintenance people, basically your staff that support the operation, maybe you've had a bunch of retirements, and so you have a bunch of new people, and they're struggling to deal with the generation of the technology that is there. Um, and there might be some new regulations. When you go into some industries, there are absolutely new regulations that inspire moving to newer generations of automation as well. In the life sciences environment, in the oil and gas environment, pipelines and things like that. There's a lot of dynamics in this area right now relative to achieving and complying with certain standards, and that varies around the globe. So there's quite a few cybersecurity. There's a lot of regional cybersecurity dynamics that are going on right now in the world that need to be satisfied with systems in some cases that already exist that need to be upgraded.
Yeah, and I realize obviously that the questions that we're discussing today are vary greatly for every company in every industry, but those are great guidelines. So just kind of looking at the availability of the hardware, the availability of the people and the knowledge to work with that old hardware, and the changing dynamics of regulations and safety. That kind of reminds me of I would imagine that when you look into a very old facility, the likelihood of seeing safety controllers in all the appropriate places where you might expect to see it now probably are not going to exist.
For sure, for sure. The other reasons to upgrade is if you have an opportunity to secure more performance, more production, better efficiencies, better margins for the products you're making by simplifying the production environment. So there's a lot of other more, I'll say, more positive scenarios as well, other than just having to comply with some new rulings. But the combination of all those things are really what needs to be considered when evaluating doing an upgrade.
So, kind of along those same lines, I know you kind of addressed this already, but if there was maybe a few specific questions that you could recommend to a business owner or a maintenance engineer to say, what kind of self diagnosis questions could you ask yourself to really evaluate whether it's time to consider upgrading a part or a large part of an internal control system?
A couple things. So I think oftentimes just it's best to just ask. And so, ask the folks involved what keeps you up at night. Maybe on the production leadership side of things, is there a particular machine that is causing more downtime than is appropriate? And so, understanding all of those constraints that companies are going through, and focusing in on the ones that are causing the most challenge. The other is if there are any new company directives or kind of in that complying with regulations scenario, but are there directives to deliver more productivity and performance and things of that nature that would merit doing an upgrade as well, reducing waste, eco compliance, and things of that nature as well.
And now I know that Rockwell works through vendor networks to be able to supply the parts and equipment. Do you recommend that when companies have questions about the method or the technology that they should be looking at specifically, maybe they've evaluated that it is time, in fact, to look at some upgrades, but where to even start with that? What options are available? And earlier you mentioned that a lot of things are modular in the sense that we can put a machine on a controller on each machine, and that means that maybe they just need to replace the one part on that one trouble machine. Can they go to the network of the representatives of the OEMs to be able to learn about what products and what solutions might be best for their particular case?
Absolutely. And so At Rockwell, we have a large ecosystem of partners. And in some cases, those are distributor partners that have domain experts on staff that can help consult with choosing the right components. In other cases, we actually have consulting engineers that can more deeply evaluate and study your existing processes and make more advanced recommendations. And then, in addition to that, we have system integrator partners and colleagues and machine builder partners and colleagues that specialize in certain areas. And so it may be a system integrator that has an extreme experience with batch. And so that's the kind of company you would want to engage with. And so there's a large um, collection of experts that can be tapped into to make those determinations in an effective way.
And certainly that would provide a lot of reassurance to a company that they're getting information from somebody who's been there and done that before, rather than just a shot in the dark, a hope this huge investment is going to pay off for them in the long run. They certainly are going to need more reassurance than that.
For sure.
Now, when we talk about companies, obviously there are differences in purposes, but there's also many differences in scale and size. And with small companies, the decisions may come down to the budget for replacing a part or all of a system. And for larger companies, the challenge may be more the logistics of replacing that many elements of a control system. So I think they both are faced with unique challenges, but there are certainly challenges there. How would you go about summarizing what those different business decisions that need to be made between a small and a large company to determine whether it's time to upgrade, if there are any differences?
Yeah, I mean, I think at a macro level, there aren't a lot of differences. When you zoom into the specifics, there probably are. Maybe the way they secure funding is different. In a multinational, multi-facility, they probably have a fairly rigorous process that you have to go through to justify, and then ultimately procure, the equipment, the machine, the automation that goes along with it. In smaller companies, there's probably not as much of a process or red tape to go through in the act of doing that. But they may also have a more constrained financial situation. So alternative methods of monetization may become useful in some of those situations. A growing and interesting area is machine as a service, and so not having to do a capital outlay for a machine, but instead essentially procuring that through as a service and approach. And so certainly not broadly adopted by any stretch of the imagination yet, but it's an emerging concept that in more financially constrained companies, they may be able to gain access to the latest and greatest automation equipment and equipments and machines in a way that is a more manageable cash flow situation.
Yeah, that as a service, I've heard that in recent years coming in a lot of different areas. There's robots as a service, and I'm sure that's an entirely different. We could have a whole different discussion on just different business solutions that make financial sense. But that is a very interesting one that people are coming up with creative ways to address some of those challenges, especially for the smaller companies that, like you said, that it's not realistic for them to just be able to drop down the funds to be able to do even what they know is the right thing to do. They're just constrained that way.
We've seen a lot of interest in these areas, or growing interest in these areas with, with the pandemic and some of the research that is going on in, vaccines and other things of that nature, and it's kind of spawned an area around this topic. And so there's kind of specific industry areas that are really interested in these kinds of more contemporary approaches.
So that kind of takes us with all this talk about approaches and what people can do to solve some of their challenges. The big part of it is looking at what is the future of PLC technology, so that the decisions that you're making now will not just be successful today, but will be able to integrate into those future opportunities. But if you could make a prediction, just knowing as deeply as you've been involved with the development of PLCs, what does the future of PLC hardware and software look like, to the best of what trends today can tell us, of course?
David, I've been looking forward to this question. The future of control systems isn't so far in the future. We introduced at our annual Rock Live event last week in Orlando a cloud-based design environment that will launch later this year. It will be a software as a service offering that will not require downloads, installs, or updates. The environment will take a software-defined approach, enabling logical design abstracted from hardware. It will be system-focused and natively multi-user. It will bring contemporary, IT-oriented software engineering practices and tools, including a native version control system based on Git. On the hardware front, history and analyst reports show that PLCs are getting smaller yet more powerful and more productive. PLCs will continue to become more performant. They'll have more memory, faster communications, all those things you'd expect to get better over time. But PLCs are no longer just simple logic controllers. In our case, they've been expanded to become multidisciplined. They are capable of much more than simple logic, including things like motion, process, batch, sequencing, and robotics. It's a long list. These disciplines have been engineered by vendors like Rockwell. Going forward, we're going to see even more modern computing capabilities in these control platforms. But the new disciplines are going to be engineered and deployed through an ecosystem able to provide advanced technologies like AI, machine learning, or modern languages. These computing surfaces will be managed in IT-friendly methods using containerization in order to facilitate more flexibility and innovation. As you can see, it's a pretty exciting time. The future is now.
So, can you give us any specific examples of companies, maybe more particularly on the small and medium sized companies, although certainly big companies provide some exciting examples, but some of those examples of where they saw what needed to be done and made that decision to do the appropriate upgrades and led to some tremendous successes for them? Are there any examples that come to mind of those situations?
There really are an amazing collection of examples. We have a website where you can go to and see a bunch of these already well documented. But I think a lot of them have been oriented around, most recently, the most exciting ones have been oriented around fusing together, AI and ML capabilities with automation. And so we've seen some of this recently in a tire manufacturing environment where some ML capabilities were deployed in a compute surface right adjacent to the controller. Controllers doing all of the classic safety and motion and all of those things, but right next to it is a complementary device that is optimizing the way the tread is manufactured. And so there are some pretty neat and advanced examples like that that we've talked about.
Yeah, and are those examples you mentioned on the website? Is that on the Rockwell Automation website? I'm sure there's lots of our audience that would love to see physical examples of some of those, maybe relieve some of their own skepticism and difficulty with understanding how it works for them. I know I love seeing examples of success, so they can just go to the Rockwell site. What would you say is one of the most exciting, intriguing examples of PLC automation that you've seen among all of the fun automation that you've been involved with in your career?
Great question. So I've been involved in many, many different things all over the world, and some of the most exciting ones for me are in the entertainment industry. And so they have just really taken advantage of the best of our automation controllers and complementary devices to make an incredibly impressive rides that probably many of you have been on. And so the seeing them behind the scenes, seeing them with the lights on, and then getting on them and traveling through the rides that result has been incredibly eye opening and impressive for me in my career.
That's fun. Yeah, entertainment and watching rides. I've heard that's a symptom of engineering is this urge to sit backwards on the roller coaster to see how everything works.
I've never done that before, but I can see how that would be a lot of fun.
So we've talked about some positive examples of automation, but perhaps there's a few learning stories that we can get out of it. Are there any examples that you know of where companies may have missed that opportunity to upgrade when they should have? And what decisions could they have made through that time that might have raised their chances of success when they were faced with that knowledge of it's finally time to upgrade, but they're faced with challenges?
Yeah, so I'm going to go back to a topic we touched on briefly a few minutes back, and it's about the fact that not only is it critical to work with the designers of the machines or equipment, it's incredibly important to work with the folks that are going to be operating and maintaining it. And so where we've seen well-intended designs of automation be deployed that didn't go so well is when the operator and the maintainers of those systems weren't consulted proactively on the approach that was being taken and whether it was conducive to using in live production. And so I've seen a number of scenarios over the course of time where that was the case. And I think probably one of the most disappointing thing for somebody in the world of automation is when that kind of a machine or piece of equipment has been deployed. Fast forward 3 months, 6 months, 9 months, and it's not being used. So that's the telltale, example where there's a piece of equipment over in the corner that's either been taken offline or is just turned off because it's either too complicated and it didn't address the operator approach in a very optimal way. And so those are a couple of examples.
With the few remaining minutes that we've got, we have some questions that are just a little bit more fun. And this one comes from the fact that a large number of our audience are either students who are getting ready to graduate or they're brand new engineers to the area of control and automation. What advice or guidance would you give to them as what topics to study? What things can they do to best prepare themselves, whether it's a career in automation or even a career with Rockwell? That's something that's in their plans. What things should they focus on?
So I would have to start with STEM coursework. It is just really a great foundation. Starting young, the first robotics scenarios, and that how that kind of parlays off into what you might do in university time. But the STEM course the courseware is really optimal, and it can take a variety of forms. If you're more interested in going into the medical device manufacturing environment, it may go down more of a biomedical path. If it's more um, in machine builders or it's more in packaging, I mean, there's a lot of specialization that can go on to complement base STEM courseware. But I think really it all starts with STEM.
I'm glad that that's been a big push in schools recently. That's a important
Yeah.
area for me as well, having a background in education. I love
So that
seeing
as a
that
base, you can
STEM.
go. Yeah, you can go just about anywhere.
Yeah, good jobs for people for sure. And now we talked about the most exciting application of PLC, but a slightly different variation of that question. What is the oldest surviving example of a PLC system that you are aware of in operation today?
Yeah, so I'm aware of a number of quite aged systems, and so I'm aware of a paper line. So they're making a rolled paper that is using controllers from the early to mid 70s. I'm aware of a chocolate manufacturing company that is making chocolate little pats of chocolate, and that is using again controllers from the early to mid 70s. And so there's actually quite a few out there yet, and they typically are pretty rock solid. But they obviously in those cases um, they haven't wanted to add a bunch of functionality to those lines, and so they're doing the same thing they were doing back when they were deployed. And so I think that really is probably the common denominator for systems that are that old, is that they're still just doing with them what they were initially.
More risk of breaking it by messing with it rather than just leaving it be and letting it do its job. And that's reassuring to know that 50 years of operation for these pieces of equipment and they're still working perfectly. That's rare to find that in a good piece of equipment.
Had to be good design.
It's a good design for sure. So, if you had the chance to build any automated machine, and I guess we could say whether it's controlled by PLC or not, just any automated machine to accomplish some task, what would that look like for you?
When I saw this in your questions before we started this, and I thought about it a bit. The thing that flashed into my head when I was at Purdue, Purdue has a fun thing that they do every year, and it's to participate in a Rube Goldberg competition. And so it's the amalgamation of just a whole bunch of things to make a process really complex. And so in some cases, and I have seen many of them done, but it may be really simple task of buttering a slice of bread. And so they go through and just create this incredibly complex set of sequences to make the process of buttering bread really complicated. And so those kinds of things are what flashed in my mind initially, because you can have a lot of fun if you were to have the power of the latest generation automation controller to make it even more complex than what usually a college student is able to do. So that was one that flashed through my head. Aside from that, more advanced rides in the entertainment industry. I know there's always dreaming up more complex things there, and that's just a fascinating thing. I think elements of space exploration could be pretty interesting. I know our company has a history of being a part of the space program in many ways, and so typically it's on the supporting environment, so the things that move rockets out to the launch pads and all of the fuel systems and all that kind of stuff, but actually more in the heart of equipment that goes off into space for research.
There's just so many fun fields and exciting opportunities that people have to use technology to advance every aspect of life. So much fun. All right.
For
Well,
sure.
Dan, we've reached the end of our time. I want to thank you so much for the time that you've given us here today and for supporting our Control Automation Day. It's been great to talk to you. I've learned a lot, and just thank you so much for your time today.
David, thank you very much. I appreciate the opportunity. It was great to spend it with you.
Well, thank you so much to Dan for the time that he's given us here today. Understanding the implications of changing technology is definitely not an easy task, but we really appreciate the insight and expertise of professionals like Dan who understand both the technology as well as the business decisions that can lead us to future success. We encourage you to check out all of the other events that we have going on at control.com today, including the launching of some new ebooks, PLC tutorial videos, as well as news and technical articles covering both theory as well as many product releases that have happened at some recent trade shows. Thank you for your involvement in Control Automation Day 2022. And remember that just by registering, you're entered in a chance to win one of a couple of grand prizes, and we wish you the best of luck. We hope you had fun and learned some new insights that can bring you success in your future career.